the first person is coined the terminology, right? Is there the Internet of Things? It's the base is in radio frequency identification, right? It's a base for yeah, the IoT. If you just see any definition, general definitions, the Internet of Things is a network of physical objects. The physical objects may be a thing embedded with electronics, softwares, sensors, and network connectivity, which enables these objects to collect and exchange the data. So, if your mobile phone is a smart thing, which is electronic devices, it has its own software, and in your mobile devices, it has its own set of sensors, and it has own connectivity. Network connectivity is like Wi-Fi, which we can say it is a smart thing, your mobile phone. So as same as like that, it's any device which is capable of having some software, sensors, and network connectivity which is capable to communicate to the external any other devices, which we can call it as it is an Internet of Things device, right? So another definition is Internet of Things or IoT refers to the billions of physical devices around the world that are now connected to the internet, all connecting and sharing data. And we can just take in the definitions from Wikipedia also. So what Wikipedia says, the Internet of Things is a system of interrelated computing devices, mechanical and digital machines, maybe the mechanical and digital machines on objects, animal or people that are provided with unique identifiers and ability to transfer data over network without requiring human to human or human to computer interaction. Automatically, the data has to be sensed and transmit to some other devices without any human to human or human to computer interactions. So that is the definitions for the Wikipedia. So, so general architecture, how the IoT its application architecture is. If you just see here, we have the physical devices like any sensors or devices, machines, or we can say intelligent edge nodes or any type of devices which is having the capability of connecting to some other devices through we can say it's maybe a router, it may be a Wi-Fi or Bluetooth or Zigbee. So through these connecting devices, right, the data will be stored, right, and they're just doing some processing, analytics, and other things for the decision making, right. At last, you just go to that collaboration process for any decision making. This is what the where the physical devices sensors to the applications where the end users. This is what the intermediate process. If you just want, we can just have a simplified thing. So the various components, major components of IoT, where the all the 7 steps will be comprised with. Yes, we have a device. The device, the thing, it may be any sensors, right? It has the capability to connect to the gateway through the wireless network. Through this wireless network here, it means through the Zigbee it may connect, or through Bluetooth, or through Wi-Fi. Along with that, we have other technologies from connecting a device to the gateway that we'll just see it later with the various technologies. As of now, Bluetooth, Zigbee, and Wi-Fi. So these are the known technologies for the short-range communications. Okay. So once it reaches to the gateway to the data transferred to the cloud, right? In the cloud, what we are doing, we're just doing some data analytics, storing the data and pre-processing the other things, and we are just extracting some informations, right? Extracting some informations. That usual information has to be visualized by the end users. So this is what, if you just take any applications, IoT applications, this is what the simplified process. So we can just have another an example where we have motion, a temperature, or any pressure. We can say it is an healthcare application. Some set of sensors. The sensors through the gateway, connected to the gateway through any Wi-Fi, Bluetooth, or Zigbee. From gateway, just connected to the cloud server. And from the cloud server, some data analytics and data pre-processing is taken place. And after data analytics is done, then we're just taking some decision, right? The decisions has to be visualized into the mobile phone. This is what the main components of any IoT applications. Where for healthcare, it comes like this. For environmental monitoring, the sensors will be different. For forest fire detection, the sensor will be different. Whereas industrial automation, where the sensors will be different. Okay. So what are the various characteristics of IoT? It may be the dynamic, and self-adapting. So whenever in the application field, we are just simply deploying the sensors, right? The sensors can dynamically adapt and with the changing context and take the actions based on their operations conditions and user context, and also self configurations. Whenever the sensors is deployed, right, they'll just send and emit some signals and form its own network into the application field. And the interoperable communication is the sensors is able to communicate any communications protocol, okay, that we'll just see later. And it has its unique identity like IP address. Each and every devices is connected into the IoT. It has its own unique identity and integrated into the information networks. And other characteristics like it has its own interconnectivity and things related services, heterogeneity, where we are just using different types of sensors will be using the application, and dynamic changes in the application field if any sensors node is dead. So initially at time t1, where the network architecture will be one architecture, where at time t2, where some sensors may be mobility, it may be changing from one location to other location, or else it may be dead. So due to that, the dynamic in changing topologies, and it has enormous scales for some applications like forest fire detections, where we have the enormous amount of sensors will be used for that application, where thousands and thousands of sensors is just deployed as like a dust particles in unmanned aerial vehicles in some forest fire detections and volcano testing range, right? It has its high level of connectivity, right? So at any point of time, any node can communicate to any other nodes in that internet. So this is what we discussed, interconnectivity. So anything can be interconnected with a global information and communication infrastructure, right? Heterogeneity, the device in IoT are heterogeneous as based on the different hardware platforms and networks, and also with the different devices, right? That's why we mean it as heterogeneity. Dynamic in changes, the state of devices change dynamically. Examples, some nodes may be in sleeping at time t1 and wake up at time t2, and some nodes may be disconnected, some nodes may be dead. At any point of time, it makes its own network due to the link failure and own topology. That's what any point of time it may changes its network structure. Enormous scale, right? We just use the thousands and thousands of devices connected into the network. Connectivity enables a network accessibility and compatibility. Accessibility is getting on a network, while compatibility provides the common ability to consume and produce the data. Accessibility, that is at any point of time where the device has to be connected into the network, right? So other challenges and issues in IoT is we have the lack of standardization, right? We have for internet, yes, we have TCP/IP protocol suite. Some set of standardization is there, but here for IoT there is no specific standards. And other challenges it has is scalability issues. That is, if you just see thousands and thousands of sensors is just deploying in the application field, right? The problem here is addressing issues. Already we have a shortage of IPv4 addresses. That is why just going for IPv6, right? That is 128 2 to the power of 128 bit address. Okay. So scalability is a major challenge, because each and every day the number of devices using consumed by the users is more. So 5-10 years back, we can say only one device, that means only one IP address we are consumed. Now each and everyone will have mobile device, laptop, iPad or iPod, okay, and other smart devices which consumes minimum 4 IP address they're consuming it. So due to this, the number of devices used by the users is increased. So because of that, we are just facing an address issues and address acquisition. Okay, and we have again, it's a small devices. There'll be issues in the security and privacy issues also, and energy issues here is each and every devices works based on the battery backup. So we have to use that energy efficiently to extend the lifetime of the network. If you're not using that energy efficiently, then obviously the lifetime of the network will be reduced. Okay, so we have to use some technologies or methods to minimize the energy consumption, and we have to. So this is a major challenges, right? We'll just see few challenges here. So Open Interconnect Consortium, it's for by developed by Atmel, Dell, and Intel, and we have Industrial Internet Consortium developed by Intel, Cisco, and GE. So all in alliance led by Qualcomm and many others. So if we these are the various consortiums, right? But there is no specific things for the IoT. Okay, there is no specific standardization for IoT. Several standards. So whenever just required, just opt and what you can say adapt and use of this some of the consortium accordingly their needs. So there is no specific standard. Scalability. If you just see here in the world population in 2003, right, connected device is 500 million, whereas the world population is 6.3 billion. But the connected devices per person is zero point 0.08, not even a one single device. It is 0.08, right? If you just see here in 2010, where the world population is 6.8 billion and the connected device is 12.5 billion, okay? So approximately 1.84. So approximately two IP address or two devices, each and everyone just started using it. One may be the mobile and one may be the laptop. But in 2015, where the world population and the connected device, see, world population is 7.2 and the connected device is 25 billion. So 3 times the world population approximately. So you just see nearly 3.47 devices will be consumed by. So 2020 we have the connected devices, average connected device we can just say it's a 7, whereas the world population is 7.6, where the connected device is 50 billion. So if 2023, just think about 2023, so it will be more than exponentially just more than the world population. So because of this reason, we are just shortage of the IP address. That is the reason we are just moving from IPv4 to the IPv6 to the 2 to the power of 128 bits range to support or to make the challenges of this scalability. So this is what the challenges we discussed, and now we are going to discuss what are design principles. So we have two design principles of IoT. One is the physical design of IoT and logical design of an IoT. So in the physical design, again it will be classified to how the physical devices is one, and then with the layers and functionalities and its protocols, right? So these are the two subsections which we have: physical design and the layer functionalities. So generally, the physical design, if you just take any devices, yes, it should have some connectivity block. It should have some processor. It should have some audio and video interfaces, or also some I/O interfaces like sensors, actuators, others. You should have some storage interface. You should have some graphics interface and memory interfaces. So these are generic block diagram of any IoT devices. But accordingly, whatever is needed, so we can just restrict accordingly, and we can just make our own design. But thing is, it should have a connectivity. Definitely, it should have some connectivity, and it should have the I/O interfaces like for sensors, right? If your interface very less, then obviously the device will be the size of the device will be very less, and also we should have some battery backup and other things. So this is a general block diagram of any IoT devices, and the interface is required. Okay, and other thing is the physical design, how the layers and functionalities and its protocols, how it works. So what are the layers here is the layers here we have link layer, network layer, transport layer, and application layer. If you just see the protocols, the layers, it's almost similar like TCP/IP protocol suite. It's almost TCP/IP protocol suite. So already the various protocols is there in the link layer. Like we have 802.3, 802.11, it's Wi-Fi. 802.15.4 is low rate wireless personal area network, right? And 802.15.1 is Bluetooth. So these are various layers for short range communications and for long range communication. In the network layer, we have IPv4, IPv6, and 6LoWPAN, whereas initially used IPv4, which is 32-bit. Now here we're just using IPv6 because of the shortage of the IP addresses. To overcome that, we are just moving from IPv4 to IPv6 is 128-bit address range, and we have TCP and UDP as it is like in the TCP and TCP IP protocol suite. Okay. Now, if you just see here in that application layer, the major thing here is we accept HTTP protocol from TCP IP protocol suite, where other protocols we are not using it from TCP IP. Apart from that, HTTP I just have COAP, WebSockets, MQTT, XMPP, DDS, and AMQP. Okay. So apart from HTTP, these are the various protocols specially designed for IoT applications. Accordingly, that IoT applications where this application layer protocols is used, right? If there is any constraint, we're just using constrained application layer protocol. COAP is a protocol. We're just using it for if there is any constraint in your applications, like message queue telemetry transport, XMPP protocol, that is presence message presence protocol, and DDS and AMQP. So these are various protocols. If you just see here, once again, just remind you, TCP/IP protocol suite, we can just use only the HTTP, right? And the rest of the protocols, it's designed for the IoT, which is why we are not using the protocols there in what we can say TCP/IP here is they are heavyweight protocols like SNMP, SMTP, DNS. So all these things are heavyweight protocols where here IoT devices are very small. Okay. So which are not capable to handle such heavyweight protocols. Okay. That is the reason we are designing or develop an application layer protocols which is capable to use by this devices, a small, a tiny devices. Okay. So these various application protocols, HTTP, COAP, WebSocket, and MQTT. So here, apart from some of the protocols you may know, so I like to explain some of the most important protocols where the most of the IoT applications are just using it. So this, hypertext transfer protocol. So the nodes clients sends a request to the server. The data is available where the server is going to respond the data. It's just going to identify what the request is and fetch the data and responds to the client. And this is what the constrained application layer application protocol. It just uses machine to machine application. It is like a web transfer protocol like HTTP. Like it just uses request and response model, runs on top of UDP instead of TCP because UDP is unreliable protocol. UDP is unreliable protocol where this is the name itself says constrained application protocol. So because of this constraint, the application protocol itself is unreliable. So this is why
So not audible, sir.
Hello, sir. Hello. Hello, sir. Ananda Kumar, sir. I think some disconnection happened. Participants, please wait in the line. Let me make it.
Yes, sir.
Can you hear me?
Yeah, sir. We could able to
Okay.
hear you, sir.
Fine, fine, fine.
Please continue, sir.
Yeah. Right, fine. Sorry for the inconvenience. Suddenly that Wi-Fi here, Wi-Fi disconnected. Mhm. Okay. So this is what the MQT broker, right? Where we have a list of softwares. Some of them are licensed and some of them are so open source, where we can just download the tool. So if you just see here, uh, we have Hive, MQ, Mosaic, and Mosquito. So if you just Hive and Mosquito, right? So we just see here the latest version of the MQTT broker is Mosquito, and it's very small piece of software. The size of the mosquito, right? That's what they meant here. Just that's why just named it as Mosquito. It's a small piece of software which can just use it as an MQTT broker. And we have other set of protocols which are just using it in our day-to-day life as like uh, what we can say in our IoT applications like extensible messaging and presence protocol, right? So these protocols we are just using it in day-to-day life. Now we can just say it's a Google Meet. It also works based on this, and we have Gtalk. Initially we just use Gtalk and Facebook Messenger, your WhatsApp. Everything just works based on this XMPP protocol. As like chess pause and vehicle tracking. So here we have Cisco WebEx, Gtalk, WhatsApp. So all these applications are just working based on this XMPP protocol. So before we communicate, we just know whether the end users are present or not. Okay. So this other advanced message queuing protocol, right? As another set of protocols. The main here is MQTT. That's why I'm just skipping these things. So what we just discussed is the physical design. Now the logical design is how Generally, the data is just communicated from your sensors to the any devices, right? So we have basically we have three blocks: IoT functional blocks and communication models and APIs. If you just this is what the IoT applications, the functional blocks with we have the devices with sensing, and we have with the communications various protocols and services for device monitoring and publishing the data, and we have functions to govern the IoT systems, and we have authentication authorizations. Okay, at last we have the applications interface that can use to control and monitor, right? And other the communication models, we have four different types of communication models. If you just take any communication in this world, definitely it comes under these four: request and response, publish subscriber, push pull model, and exclusive pair model. Request and response we already discussed with HTTP protocol. Publish subscriber model we already discussed with in MQTT protocol, where the client we have the publisher and MQTT broker, and we have the client as a subscriber. Whereas push pull model, where we have the publisher send a message, right? They just send a message, so the push into the queue, whereas message pulled from that queue by the consumers. This is what the push pull model. And whereas exclusive pair model is a bidirections with request and response, data and acknowledgement, and for connection requests and connection close. Such we have the exclusive pair model. If you just see where all these four communications, okay, will be working in any applications. So I'll just skip this just for some the time constraints. Okay. Now we have just seen not only IIoT, what are the technologies behind the IoT is. We have RFID technology, we have mission-to-mission technologies, we have IEEE 802.3. So due to time constraints, I couldn't explain this each and every technologies. Just for your information, I'm just sharing this technology behind this IoT. 802.15.1 Bluetooth, 15.4 low rate wireless personal area network, wireless sensor network, cloud computing, big data, cellular communications. So NB IoT, and then Z-Wave, embedded systems, and we have LoRaWAN, and we have weightless, NFC near field communications, Sigfox. So these are the various technologies behind an IoT. Right, now just come to the point. The second half of our the main presentation is what are the various applications. So we have just using the applications of IoT in transportation and logistics, right? Like logistics and assisted driving and mobile tracking, environmental monitoring, and augmented maps. And healthcare, we're just using tracking, identification, authentication, data collection, sensing, and smart environments, personal and social and futuristic, robot tax and city information model. So we'll just see some general applications, and along with that, we'll just go with how the IoT will be used in the mechanical systems and other industrial IoT, right? If you just see generally, right, where the diverse application is, the IoT will be used in the smart city, where you can just go for the proper electrical distributions, and we can just use it for maintenance and surveillance, and utilization of the smart grid and emergency services, and just going for, and also we can use it for the waste management. Whereas in buildings, smart infrastructures for lighting, electrical and transit and emergency alerts, we're just using it. And for healthcare, we're just using it for patient care, elderly monitoring, and remote diagnostics. And for transport, we are just using for traffic routing, telematics, package monitoring, smart parking, and insurance adjustments, supply chain. And for home, we can say smart house monitoring. We're just using it for smoke alarm, right, and other washer or dryer or energy monitoring for the various household appliances, right? And you just know. So the smart parking system, where even in some cities, before just reaching into that mall, we are trying to get the available slots, because finding a parking some locations like highly crowded or what we can say malls, it's very tedious, and that's very problematic one. So what we are just doing, where the system IoT system is allow, once we are there in the in that region or range where we are supposed to get the available slots where we can just go and park our vehicles, right? And efficient waste management systems and smart cities. Yes, we have the waste management systems. So here, if you just see the one, okay, where we have garbage cans with low cost passive sensors and garbage cans with an active sensor. So here, due to that short range communication, where the sensors is communicate to the infrastructure based network, where the data will be communicated to the node, or we can just maybe the gateway. So from gateway we are connected to the cloud platform, right, where the data will be stored, okay. And then if the garbage cans are full, okay, so what they will do, the garbage truck, after just seeing those, they will just come and collect the data and update the information. So the can exchange informations will be displayed into the council, city council, and recycling plant, on manufacturing plant, and health and safety authorities. So this is what the general IoT application. Where here, how can you just say it's an IoT? Because where the sensors plays a major role here in the garbage cans, and we have the short range of communications which is placed in that pole. So from here, through Wi-Fi module, we are connecting to the cloud services, right? So these things will be done automatically, okay. And an IoT application is shopping, where we are, whenever just entering into the doors, the scanners will identify the tags on her clothing, and when shopping in the market, so the goods will introduce themselves, their features, and their maybe the features and the cost and other things. And once we just move, so when moving the goods, where the reader will tell the staff to put a new one, right, if it is empty cases. And also the payment will be done automatically through our credit card, okay. And healthcare, which is using how much I slept and my walking and other things nowadays. So this application is commonly used by everyone. I hope you know all those things. And we have what we can say, it's home automation products, right, like Google Nest. It's to create the thoughtful home, where internet connected security cameras for inside and outside the home, right, and a thermostat that uses motion detecting sensors to detect when the owners are about, where the camera is equipped door. So we are just using various IoT based devices, cameras and sensors to monitor our home, and also to track of anyone or any intruders in that. And also we're just going to check, and alarm will be generated if there is any smoke is detected into that home. So this is a product, Google Nest. And other VPET tracker Pod 3, so where we can just tie these devices and we can just monitor that our pets. And baby monitoring, so Mimo, where we have the other baby monitoring devices, we can monitor even from the remote location, where the data on body position, sleep activity, skin temperature, respirations, and as well as live audio will be there. So now this is what the general application we discussed. Now we're just moving on to that, how the IoT will into that industry. So we simply call it as the industrial Internet of Things, right? So industrial Internet of Things refers to extension and use of Internet of Things in industrial sectors and applications. So with strong focus on machine-to-machine communications, big data, and machine learning, and other efficiency reliable things will be there. So apart from IoT in industry, where other supporting technologies also be needed. So again, here is, as we discussed, instead of sensors, like we are just using the industrial things, right, like PLC and robot and other sensors. Again, as we see in the second slide, where the industrial things will have their connectivity. So from connectivity to the cloud platform, and from cloud platform to that, we can just with the remote devices, we can just check and monitor whatever just the current parameters or measures is there in that industry. So how IoT and IoT differs is utility. it is mainly designed for the individual customers, where IIoT is just used in commercial area, that is industry. Security is not an issue in IoT, whereas security is a major concern in IIoT because of the costly devices will be there. And the degree of application, it uses applications low risk, where more sensitive and precise sensors. And cost is really industrial IoT just have the expensive when compared to our own IoT for the end users or small applications. So we can in this picture it can shows industrial Internet of Things. What are things will be there? We can use it in a smart factory, smart grid, and smart machineries, and smart city, and smart car, and all those things. Whereas for the consumers, we have smartphone, smart wearable devices, smart TV, applications, and home. And what is IoT, IIoT, and that is Industry 4.0. So Internet of Things pertains to customer and commercial sectors, whereas industrial IoT pertains to the industrial sector, enabling the force for, because of IoT, we just enabling it just to develop that Industry 4.0, the connecting our devices, our data, our machines, and our people to benefit for company and consumers and manufacture the best possible products, right? So where IIoT is for Industry 4.0, so focus primarily on the manufacturing sectors, okay, represent the integration of IoT and relevant physical technologies, analytics and additive manufacturing, robotics, artificial and cognitive. All these things comes together, we can say it is an industrial 4.0. Now we just see some of the things in industry 4.0, how it is evolution. So first, industrial revolution 1 is for mechanization, steam or water power plant, and 2 is for mass production, electricity and telecommunications, whereas industry 3 is computation automation. Whereas industry now, we are just integrating that Internet of Things, right, and cyber physical systems and predictive analytics. So main thing here is integration of IoT and industrial Internet of Things, right? We can simply say it's an Industry 4.0. The fundamental to Industry 4.0 are the sensors, device, computers that are connected, communicate with one another, to ultimately make decision without human involvement. By that is IIoT. So this is what Industry 4.0 and Internet of Things, okay, which we call it as industrial Internet of Things, right? So benefit of Industry 4.0 is improve the resource utilization, increase the productivity, and cost reduction. Cost reduction here is, we can just say, where something is just going to happen in future, any issues in their machineries or in the production. So where we can just predict. So based on that, we can predict it, and accordingly we can just make the changes in that production. So accordingly we can just reduce the cost, okay, and increase the productivity based on what we can see with the current data, with some data analytics process, with the help of machine learning or AI, we can just increase the productivity. So I'll just skip these things. 5G for Industry 4.0. Mainly what you're just doing, sensing, processing, and intelligence in the device itself. So other applications and performance and productions increase by reducing the downtime. So I just given the link. So here in this link, what they just used is with the help of industrial IoT, where they increase the production, and also they just they minimize the troubleshooting in the industry. That's what just given in this YouTube video, right? And other industrial Internet of Things applications here is, so we can just use with the help of IoT, where microgrid